Did you know that the micronutrient selenium is an important building block in the protection against certain free radicals, and it does not work equally well for everyone? In this video, I'll explain why and what role your genes play in this. After inhaling, 5% of oxygen is converted into the free radical superoxide. In the optimal case, the SOD2 gene is immediately present and converted into hydrogen peroxide as the first step of detoxification. However, this is still a very aggressive substance. After all, it can be used to bleach hair. Our body needs a way to make this substance harmless, and evolution has given us the GPX1 gene just for this purpose. However, for it to fulfill its task, an important building block is needed, the trace element selenium. Let's take a closer look at this process. Oxygen enters the body and is eventually converted into aggressive hydrogen peroxide. Now it's the GPX1 gene's turn to produce the GPX1 protein of the same name. This only works with the building block selenium, which we must obtain through our diet. Selenium is integrated into GPX1, and now the battle against hydrogen peroxide can begin. The substance is recognized by GPX1 and converted into harmless water. Therefore, sufficient selenium and a functional GPX1 gene are essential for the protection against this aggressive substance. But now comes the problem. There's a common genetic defect in the GPX1 gene that does not completely destroy its activity, but drastically reduces it. With sufficient selenium, it can still neutralize hydrogen peroxide, but much more slowly and poorly than the optimal form of GPX1. What can be done in this case? Interestingly, studies have shown that a significantly higher intake of selenium can also increase the production of impaired GPX1. Although these are still weaker than the normal GPX1, they are available in much larger quantities. As a result, protection against hydrogen peroxide was also increased in the study. So how common are defects in the GPX1 gene? Like most genes, we have two of them. One comes from our father and one from our mother. About 62% of people have inherited two functioning GPX1 genes this way and have good protection against hydrogen peroxide as long as they are adequately supplied with selenium. About 33% of people have one normal and one defective GPX1 gene, resulting in reduced protection against the free radical. The remaining 5% have two defective genes and very poor protection against these free radicals. If you believe these studies, a high intake of selenium has the potential to significantly increase the protective function of these genes. So you see, our genes can influence whether a normal amount of selenium or a large amount of selenium can lead to the same goal.